Okay, this video is a very fast overview of the functions unit. So one of the first skills you need to know is knowing how to take a function, which is a equation with two unknowns. So we've got our unknown of x and y, and you need to be able to display that function in a table and in a graph. And then we're going to talk about a couple things, and hopefully you're going to see some patterns. All right, so we have, if our x value is 9, we take our x and add 3 to it. So negative 9 plus 3 is going to give me negative 6. If we put a 0 in, 0 plus 3 is 3. You put a 3 in, 3 plus 3 is 6. You put a negative 2 in, negative 2 plus 3 is going to give you positive 1. You put a 7 in, you're going to get a 10 as your output. Now these are ordered pairs, x, y, negative 9, negative 6. If you graph that ordered pair on a coordinate plane, it's going to be right here. 0, 3 is going to be 0, 3. It's going to be right there. 3, 6. So 3, 6 would be x value of 3, y value of 6. There it is. Negative 2, 1. Negative 2, 1 is going to be right there. 7, 10. 7, 10 is going to be right there on the graph. Now you know you're doing this right when they all line up. These are linear functions. They create lines. And then what type of function is this? Well, since we're adding something, it's additive. The slope of this line, if you look at it carefully, it's basically going up 1, right 1, up 1, right 1. Once again, there's a video covering slopes that goes a little deeper into it. This is a quick overview. The slope is 1. The y-intercept is hitting the y-axis. The line hits the y-axis at 3. So the y-intercept is 3. Now, if you notice, the y-intercept is the constant that's in the original equation. We're moving on. Y equals 3x. This time we're taking all of our inputs and we're multiplying them by 3. So if my input's negative 3, my output is negative 9 because 3 times negative 3. If I put in a 0 as my input, 3 times 0 is 0. If I put in a 4, 3 times 4 is 12. If I put in a negative 4, we're going to get a negative 12. If I put in a 2, we're going to have a 6 as our output. So now let's graph these points. Negative 3, negative 9 is going to be right here on the graph. 0, 0 is the origin. 4, 12. 4, 12 is going to be over in quadrant 1, up pretty high. Negative 4, negative 12. That's going to be negative 4 and negative 12. There it is. 2, 6. 2, 6 is going to be aligned with x value of 2, y of 6. They all do line up. It is a linear function. That's supposed to happen. Since we're multiplying by 3 each time, this is proportional. Once again, you'll want to check out another video called Additive versus Proportional if you're not sure why this is working. The slope, if you look at the slope, we're basically going from one point to the next, up 3, right 1, up 3, right 1, up 3, right 1. That's a positive 3. The y-intercept is at 0. Moving on. Y equals x minus 5. I'm going to quickly make the table. Negative 7 minus 5 gives me negative 12. You put in a 5, your output's 0. You put in a 3, your output's negative 2. You put in a negative 2, your output's negative 7. You put in a 12, your output's 7. So now let's plot the points. Negative 7, negative 12, negative 7 on x, and negative 12 on y. It's going to be down here. 5, 0 is going to be an x value of 5, y of 0. It's going to be right here on the x-axis. 3, negative 2. 3, negative 2, x value of 3, and then y value of negative 2. Negative 2, negative 7. Negative 2x, y negative 7. There it is. 12, 7. X is 12, Y is 7. You're going to be putting it right over here. They all line up. Is it additive or proportional? Seeing that you're doing some subtracting, that means it's going to be an additive relationship. Your slope, up one, right one, up one, right one, up one, right one, it's 1. Y-intercept, it's hitting the y-axis at -5. And once again, the constant is -5. Moving on. Y equals 1/2 x. If I do half of -8, I get -4. Half of nothing is nothing. Half of +4 is +2. Half of -12 is -6. Half of 10 is 5. -8, -4, if we plot that on the graph, -8, -4 is going to be in quadrant 3. 0, 0 is the origin. 4, 2. X value of 4, y is going to be 2. There it is. -12, -6. That's -12 on x, -6 on y. That's where they align. 10, 5. We've got x of 10, y of 5. There they are. Connect it, you got a straight line. This would be a proportional relationship. It's hitting the origin, and it has a slope of up 1, right 2, up 1, right 2. So the slope's 1/2. The y-intercept is hitting at 0. Once again, there's a video called Additive versus Proportional. You want to check that out for more details on this. All right, moving on. Spotting if something's additive or proportional, and what is the equation? Looking at this first one, you can look at this -5 turning to -11, 0 turning to -6, input of 3, output of -3. Couple ways you can check this. You can go ahead and see if the y minus x all works out to the same thing, or you can do y over x. And once again, I've got that additive or proportional video that goes into more detail. This would be an additive table. Its equation would be y equals x minus 6. If you look at all of your y minus x is -11 minus -5, they all, -3 minus 3, they all work out to this -6 constant. So this next one, we've got -5 to -30, 0 to 0. This should be hopefully a big giveaway for a lot of you. 3 to 18, -2 to -12, 7 to 42. It's going to be a proportional relationship. This is proportional. The equation is going to be, what am I doing to that x to get the y value? I like to look at the positive ones. You could go, hey, what did I do to 3 to get 18? I had to multiply it by something. I'm multiplying by 6. Probably the quickest way to figure out what that common coefficient's going to be is to just do -30 divided by -5. 18 divided by 3, -12 divided by -2. They all work out to a +6. Your slope is 6. Your coefficient is 6. This last one, -5 to 1, 0 to 6, 3 to 9. Once again, let's look at this positive here. From 3 to 9, looks like you're sure adding 6. It's going to be additive, and it's going to be y equals x plus 6. And once again, you can go, hey, 1 minus -5, 6 minus 0. All of your y minus x, 4 minus -2, they all work out to that same constant. This line would have a y-intercept of 6. We're moving on. We're going to go ahead and take word problems and make them into graphs. The first thing you would need to do is translate this statement. James' age is, J equals 3 years more than, 3 years more than. Kelly's age, Kelly's age. Ideally, at this point in the year, you'd be able to look at this and go, oh, this is an additive relationship, and my y-intercept is going to be 3. Additive, y-intercept 3. Immediately, you should be able to go, oh, that means the y-axis it's hitting at 3, and I'm going up 1, right 1, up 1, right 1. So the line's going to look like this. Now let's say you didn't have this down just by looking at the equation. You could also create a table. You could go, oh, well, let's say if Kelly's 2, if she's 5, if she's 9, what's going to happen here with the age? And then you could do 2 plus 3, and you could double check that it aligns. Hey, 2 plus 3 was 5. It's on the line. If I do 5 plus 3, it's 8. Is 5, 8 on this? Yes, 5 and 8. If Kelly's 5, James is 8. It does line up. If Kelly is 9, and you add 3 to it, you get 12. So if Kelly's 9, he's 12. 9 and 12 are on the line. We're going to move on. Nikki rides her bike at 2 miles per hour. So we want an equation and a graph representing her distance for the hours. Distance is going to be 2 miles per hour. That's 2 miles for each hour, 2 times h. Now ideally you'd be able to look at this and say, oh, this is proportional and it's a slope of 2. With that in mind, you'd say, oh, proportionals always start at 0, 0. And then if the slope is 2, that's up 2, right 1, up 2, right 1, up 2, right 1. And the line would look like this. Once again, you can always make a table. You can go ahead and set it up for hours and distance. If she rode 2 hours, well, 2 times 2 is 4. Is 2, 4 going to be on this graph? 2 hours, 4 miles, there it is. 5 hours, 2 times 5 is 10. So in 5 hours, that's 10 miles. There you go. If you did 6 hours, 2 times 6 is 12. So in 6 hours, she would have rode 12 miles. 6 hours, 12 miles. She's pretty far from home. Hope she gets home soon. That is about it. I hope this helps. Best of luck to you.